the lavaliers, because it's kind of useless to do this without audio. I'm gonna go get the lavaliers. I'll be right back.
Where's the microphone? Where's the microphone? Yeah, we have like a presentation every week on something.
Very bad.
Yeah, we have like a presentation every week on something.
Very bad.
It's fine.
It's not that. Oh, it's
You get the microphone's somewhere on the table, so.
okay.
The microphone's somewhere on the
Well, okay, sure. Yeah, that actually doesn't sound bad at all. Okay. Well, maybe I don't need to. Oh, I do enjoy talking to theater people, but maybe we don't need to go do that anymore. Okay, cool stuff. All right. Welcome, stuff. Oh, look at that. I forgot that little transition. Welcome, guys. Very small today, but that's okay. I know that a lot of stuff people couldn't come because of that, but either way, I love that we have this. I'm gonna play around with the cameras later on. Like, we have some crazy stuff, and I think those cameras even like can track me. So like, if I start moving, they'll track me or whatever. So cool stuff. So yeah, today we're talking about genetic algorithms. I don't think anyone, only Jonathan, you've been here before when I talked about this, right? No one else talk about this? No? Okay, so first time I meet you, so definitely not. But yeah, so what is this about? So when we talk about genetic algorithms, we're talking about basically a way to solve problems that have basically infinite solutions. Obviously not the optimal solutions, but we are trying to find something as close as we can to an optimal solution using a Darwinian process. Okay, and this is what has made the roots for how AI works in a lot of things. Okay, so not to get too confused. Oh, hi, how you doing? Not to get too confused exactly with that, to think that AI works exactly like us. It does not, in a lot of different purposes, but at least this can work a lot in the way that maybe we learn stuff, and in the way that also we evolve as humans, and more than anything, how creatures evolve in a game scenario. Maybe I'll explain that after, but I don't want to. I could go explain the game theory part for a long time, but so I'll first start with basically in the programming base how it looks. So I forgot, this presentation is amazing. Yeah, you'll see. Beginning. So this is the outline for a program. Okay, a loop for a program. Okay, very simple. We have beginning, initialization, initial population. What does that mean? You'll see. Take a look, this little thing here is what will be more important. So what does this mean, like quit at the beginning? Is that we will basically generate like a random solution, and if this solution impossibly is like just randomly we generate like the best solution that we can, is the best, then we quit, right? Because we already have the solution. But that's very, very, very unlikely to happen, whatever. But then we do this. So we have a selection process, crossover, mutation. Sounds a lot like the Darwinian evolution, right? And it kind of is. But basically, we do that with our population. We generate a new population, and then we check again, should we quit? And that's how the loop works, basically. So we run this, we check if our solution got better, we quit, no, then we keep going. That's it, a loop, okay? Now, So initialization, we have a random population. I just talked about this, but yeah, basically, when I talk about population, you can't think about it in the way that you think about animals. We have a population of animals. Some might have some advantages over others, right? Random advantages, evolutionary advantages, mutations, right? So yeah, the best solution, okay? So we give basically a form of a score to the solution, okay? So what does the best solution look like? This was actually specifically for a pathfinding algorithm. So if you think about this, it was for a Roomba. But basically, you have this floor, right? And you want to cover the entirety of the floor, right? But you want to do it the most efficient way possible. What is the best route to cover the entirety of the floor the most efficiently, right? The solutions for that are basically infinite. You go forward one square, and then you go top, let's say that we are talking about like in coordinates, we're going like, and I should do this to the camera, but whatever. We go like left, up, or whatever. We start doing whatever type of pattern, right? How can we guarantee that that is the best solution? We go especially by parameters. So the shortest route, basically we count how many squares we travel, simple. Least turns, the least amount of turns, because every time you make a turn, you are losing speed. So basically you're trying to make as much straight lines as you can, because that way the robot is traveling faster. We're trying to make a best type of robot, right? Least or no overlap. So why would you want to cross like the same path twice if you already cleaned it once, right? So that's, and best solution is this number as close to 0 as we can, this number as close to 0 as we can, and this number as close to 0 as we can. So basically all of my solutions, right, are basically the 100% is basically inverted. So if you're close to 0, is closer to 100. If you're far away from 0, it starts diminishing, right? So as you can see here, so when we start, and what I would do, basically, I would have this room right here, and I just generate a random route that goes over the entire room. It's gonna be shit, okay? It's gonna like have a lot of crossovers, and I don't have the simulation that I had there back then before, but basically it's just those random paths in the room, basically, and then it counts basically for all those parameters that I added, and that gives me this, which fitness, okay? So this is how good the solution is according to all those parameters that I added, right? It gives me basically a percentage of in nature it will be survivability. Like if an animal has certain traits, it makes him more survivable, right? It makes him more likely to reproduce, and therefore is more likely to go into the next generation. So that's what that says over there. This is kind of how like the formula, nerd shit is fine, but this is how you would end up like applying it in the algorithm. I don't have it here, so it's not as fun to look at. It's more fun when I have like the actual algorithm here. I just set this up, so I don't have it here, but maybe for next time. But natural selection and immortality. So this is how it's selected, okay? So basically, whatever your best solution is, you make that one immortal. So basically, you copy paste that solution into the next generation. That's why you got Giga Chat right there. So that he just gets copy pasted into next generation. We do that to ensure that like at least our best solutions keep transcending generations. He's probably not going to be the best solution in the next one. On average, they start, and I'll explain how they get better over time. But basically, you add all these solutions to basically a pool of selection, and the chances of each thing being selected are equivalent to their fitness. Okay, so for the next solution, I need to pick another 5 members, a new 5 members. Okay, and those 5 members need to be children of 2 of these guys. Children of math, which it's basically you're just making children of numbers. How do you do that? You're combining them. I'll show that here in a second. But basically, this guy, this guy's gonna have the biggest chance to cross over with other solutions. This guy's gonna have the least. Okay. Why don't I eliminate my very unoptimal solutions? Because I know that this is by far like the worst. Why don't I eliminate it? Because, well, it will be kind of eliminated over like natural selection, but I still want to keep everything, because there are, well, the amount of like complexity on it makes it so like even unoptimal solutions at the beginning can turn into optimal solutions after. So we try to keep as much as we can, and you just leave it up to chance, which is like, why would you do that? But when you run this basically like 10,000 a million times or whatever, it tends to basically like give you amazing results. Just not just good results, like beyond what you could have imagined yourself good. That's how, and then that's how you like go into AI and things after. But yeah, so and interesting stuff is that's due to randomness too. Like this is we are using random, like a lot of random generated numbers to do this in not like in a just fully random way, but like in a methodical way, right? I like this one. And my fitness is below. It's very unlikely that you will go to the next generation, but you know. So yeah, this is what I was talking about, kind of. So yeah, mutations too. So basically, we have our solutions, right? And to get your next population, you do crossovers, right? And in each crossover too, we have mutation chances, okay? You can increase this, decrease this, whatever, but basically that's, in the solution, basically a number, you just flip it. Like whatever it might be, you just flip it. And I have, this example on genetic code goes out. Yeah. So, yeah, and as I said too, the best solution just gets copy-pasted into the next generation. But it is very likely that these other solutions that went over crossover and like basically that this evolutionary process, you guys gotta go, it's fine, no worries. They will improve in the next one, okay? So the crossover point, when we this is what the path and like all of the grid look like, okay? And there's a lot of numbers and a lot of stuff here, but basically this is how you kind of keep track of like the DNA of the code that you're generating, of the path that you're generating, right? So for example, things like this, right? The crossover point, and that's how you do basically a crossover. You have these two solutions that got put into the next generation, and they're going to do crossover. Basically, you just flip them in the spot that they do. So basically, if you see it like this, instead of like crossing in here, they basically would just go straight, okay? So that's one of the like intentional tweaks that you add to it. And then you have mutation. So mutation is interesting in this part, right? So basically, it's only a 2% chance, right? Once you have like the children, then you run a mutation chance. The mutation chance is just being 2%, so it doesn't happen that often. But if it happens, basically it runs this other subcode that basically chooses one random cell in the DNA. This is the DNA. It chooses one random cell. Let's say it chose this one. Then it takes all of the ones that are adjacent to it, and it picks a random one. And then it obviously needs to maintain cohesion. So basically, if it chose 66, I need to add also the. It chose 79. I don't remember how that part exactly. No, it chose 66. You have to add 79 to it, so it keeps cohesion basically. Yeah. So if you need to, you will have to add something. Otherwise, like there's no way that like you gotta think that it's also meant to be like something in the real world. So the robot can't just like somehow like grow legs and jump, right? So there cannot be holes on it. So there needs to be consistency. And yeah, that's it. So let me just talk about this part here really quick. So when it comes to basically the selection part, and if you guys, I showed you then a TensorFlow, right? Did you check the TensorFlow, like the playground thing?
Yeah, what about it?
It's not shown on the screen right now. Why? One second, sorry. Oh my god. There you go. And I'll show that here in a second, right? But this looks a lot like that, right? Because it comes from it, right? Obviously, in TensorFlow, there's a lot more intricacies, and I'm working on that right now. We'll talk about more about that after. But yeah, it comes from this, right? It comes from basically solutions. Those solutions have children from the solutions like combining with each other, and then that just spits out another answer. And it's this is, I find, the easier way to do this, because if you just talk in numbers, like this gets very bizarre very fast. Because when I'm doing this, what I'm basically doing is I'm just cutting numbers in half and just like smashing them together, which it shouldn't make too much sense. But yeah, so yeah.
Can I ask questions?
No, of course, yeah. And
What is your main question you want to answer though?
about with this, well, for this one, you mean with like when I was making this algorithm?
Yeah. What is your question?
Well, that's what I was talking about. This part over here. This. We have a robot that is gonna clean the floor. Okay, Roomba. You know, and I want to make the most optimal path for that Roomba to go, to not waste anything, like to not waste any energy or anything. So the Roomba knows the what's around, like it knows what like the room, it knows that there's obstacles on the room. That's what, so yeah, if you actually, yeah, let me go over there. So think about it, this could be a room, right? This is like a table and so a couch, okay? And the Roomba has to clean this entire thing up. Like there is many ways to like do some algorithms to like solve for this, but from what I saw from multiple experiments, this algorithm beats anything else that you can find, basically.
And with this, what do you want to do with genetics? Like you want to be able to find the best pair?
No, okay, so maybe I wish I don't have the program here, but basically no, what it does, this, it's so much better if I have it, but this right here, right, this genetic thing, right, is a track, is a piece of track that the robot is going to go through. So the robot would go from here to here. That's the DNA part of it, right? The robot starts here and goes here, and that's one. But there's basically, randomly, I generate basically the entire thing. So until it covers the entire thing. So basically, it starts here, then it goes there, it goes there, it goes to like all the points, right? Randomly.
So the main thing is a robot that goes throughout the whole place and has to hit every square box without
optimizing for this. That hits every square and optimizes for this.
okay.
Yeah. Maybe I should describe that at the beginning. I had the program and I could have shown you, but I don't have
Yeah,
it.
because with the genetics that's confusing. That's a different algorithm.
Well, no, it is. That's how I solved it.
Okay.
So I basically
You
when
want to combine them.
I think there is. Let me see. No, it's not a combination. Let me see if I can show that to you right now. Let's see.
You're using one way to solve another one.
What do you mean?
You're using the genetic, how it's used the genetic algorithm to the robot in a pattern. Is that what you're trying to say?
Are you talking about the AI stuff that you do, or?
Because I thought that's what it was,
No, well, so this is like the lower version of that. Like that is like that is like, so when you talk about TensorFlow, like using TensorFlow, you did some problems with it, right? Like I remember you told me that you did the one for the. I'll show you for because people don't know what we're talking about right now. So it was playground.tensorflow. Playground.tensorflow, right? This thing, right? And you have to basically choose how to solve this, right? Is this what you mean? Now, so this is solving. That's the interesting part. You can use this to solve anything, right? Because anything that this is made to solve for like a visual image, right? You're trying to make it so the computer can recognize that this is a circle inside of a circle, right? What mine does, right, is optimized for something else. It's optimized to find the route with those parameters. What your in this thing does, right?
Yeah.
But it uses the same process though. So basically, when we have these guys, right? This guy says like, okay, let me try this starting point. And this is like the initial population. You see that it's basically saying that, if you see it like that, right? This is the initial population. The population meaning solution, okay? The initial solution that the computer just goes and tries is basically, let's just split it in half and see if this is correct, okay? But what happens? All of these blue guys, right, that are in the incorrect spot, they are gonna decrease that fitness, the fitness. Remember the thing I talked about, the thing that makes it more survivable, more likely to go into the next generation? So every time it does a mistake, it's gonna basically decrease the amount of survivability that it has into the next generation. And then what else do we have? We have the X2 over here, which does pretty much the same, right? But now what happens? So they realize that there's a lot of things wrong, and that gives them like a fitness level, right? And then after they get that fitness level, they will combine themselves. They'll do some randomness. They will probably use also these things to random it themselves, like in other ways or whatever. And in that randomness, right, there are some that are going to be better than others. Okay, some of them will like do the line is going to get inclined a little bit here, a little bit there, right? Those are more likely to survive into the next generation. Does that make sense? Mm-hmm. That's kind of what that's doing here. But like this is like the way more abstracted version of it. Okay? They use like a bunch of other stuff that I don't know completely understand, but I understand the principle behind it. I know that that's what they're doing. I know that there's like some extra stuff on like the neurons or whatever, but for example, like when they say neurons, like the neurons get strengthened by how do they get strengthened? They get strengthened by how correct they are, right? That correctness is basically the same as the fitness level. So like how survivable they are, how good they are in the challenges that you give it, right? So my challenge, the challenge that I gave it was, you have this random set of numbers that make up basically the entire route to complete this space, okay? And every time that you do one of the mistakes that I described, I'm gonna decrease your score. Same as this, right? But this one, and let me run it so you guys can see it too. I don't know if anyone else has seen this. And epoch is the amount of times that it has done an iteration, right? I think so, right? Yeah. But basically, yeah. And you see that, and then it generates this as the solution, right? So like when it gets here, when it gets to this, is that it has made a formula to receive this image as an input, right? It receives the image as an input, right? And it can declare where all of the dots are just by running it through like basically like a math formula that it has internally. The math formula that it has internally to declare where anything goes is basically created by like iteration, and all of those solutions are basically, you can think about them as just like animals. Some of them are better, some of them are worse. The better ones survive over the worse ones, and that's how that happens, right? So, yeah. So, I lost my train of thought. It gets more complex too, and just even solving for this type of stuff also is like another problem by itself. But like if we go to like the more complex stuff, like this guy or that, I know that this guy is like super hard, right? And it has because it has a lot more room to make like way more mistakes and all that. I should add some more neurons or whatever. But those are each of these are different like ways of iterate through like the each of these are ways to you see what this guy became and what all of these guys became. They're different like children of what came before them, right? You see that these guys are like all different, and these guys start to be different, and these guys start to look more like this guy, right? They are all trying to adapt to their environment here. and then it starts going crazy. But oh yeah, so what I was talking about, like with the neuron, right? The neuron gets strengthened by solving itself right, and those pathways, all those pathways, the solutions that created this thing, are basically just just based on like which ones were randomly right and randomly wrong, but we give a bias to the ones that were right over generations. Does that make sense?
Mhm.
Yeah. So yeah, any other questions? Okay. So cool. Well, let's see how.
Like artificial intelligence
Yeah.
is a byproduct of us having a lot of computing power, right?
Oh, you just told me I was. Thank you. I was like, I'm forgetting something. Yes. Okay. So one thing. Why is this even useful? Because making this, you're solving for this one thing. Like I could have done that, right? Like I could have said like, okay, that's a spiral, right? I could say like, I can look at it and say like, yeah, that's a spiral. Why is it even useful? And by the way, this just took like 3,000 like loops of iteration to just declare that thing. Why is it even useful? No ideas. It's fine.
Image processing?
What's that?
Image
Well, yes, but the thing is that if it has to run 3,000 times before it can process an image, why is it useful? How can it be useful? The thing is, I'll tell you what. The training is the only part that is expensive. If you train it and you get the results that you want, at least like 99% of the time, the run through is very fast. So like you see that like it has done it 40 times over the time that I've been talking to you, right? Basically, it would be able, if this is trained with like a 99 success rate, is basically gonna process images. Like it will have processed like 4,500 images over the like nothing. Okay, without using any like hardcore processing power. It's actually very cheap to run through this. What is actually very heavy is to actually get the good results. It's not the good results not even there right now. The good result is to be like basically kind of perfect, like a perfect thing, right? So when it is, as Jonathan said too, before it was basically impossible. Like training this thing, like on like the more because this is baby stuff, right? Like this is baby stuff. Imagine like we're trying to like find the spiral here, but like what is this is actually useful for is like when Google wants to find if there's like jihadists killing people in ISIS videos, kind of like taking that out of YouTube at a like expedient rate type of thing. That's like one use I can think of it. But like the other use that I was just looking at is basically like sentiment analysis. Basically running through like just pages of articles, like the entire pages and articles on YouTube and things like that. Not YouTube, in any like all over the internet, right? Reading the entire thing, and this is so interesting to me. Is that you read through the entire entire article, and the computer will give you basically the author has a positive or negative opinion about this company. This is they use it for stocks and things like that. For it's basically the biggest use for you guys have seen Micro Reeves. Anyone seen Michael Reeves here? You've seen the fish video, right?
There's a piece of weeds. Which one?
The last one he made, but basically he made one that he basically created a neural network that would analyze like that funny the Wall Street Bets subreddit. Do you guys know about that? The guys that did that the GameStop meme stock, and like they're still being scammed by GameStop. No one knows about that.
Yeah.
Basically a bunch of degenerates that use the stock market to bet. But whatever. So basically, he made a robot that would analyze the sentiment that this subreddit that has like thousands of posts every day. So it would be basically, let's go in it, whatever. Let me show you what true insanity looks like. I'll tell you, and obviously this is like this is like a meme example, but you'll understand why it's useful when you see this. Okay, so basically you have like every day, I don't know how to check the things on subreddit. You have like 12.9 million people posting. Is this? Oh, this is. Oh, so they have 47,000 active users. Like I don't know if this is weekly, daily, whatever. But you have a lot of posts every day, and it will be posts that say like things like this. Hey, Cotopaxi, what the heck? I'm from Ecuador. What the heck? Why is this here? That's an ad. Oh, I don't use Reddit too much. But basically, yeah, it would sift through all of the posts here, right? And it would determine if the poster had like a positive or negative review or of a certain company. That's basically what they do here. It's like they say, on this stock, gain. On this stock, lose. And basically you analyze the entirety of the posts that day, and that gives you this company good, this company bad. Obviously, these guys are idiots, so basically you get like bad results most of the time. And he did, but whatever. But what that shows is that he could use a robot to analyze what like 40,000 people felt about something, or like the average of them felt about something, right? And that's because he trained that robot. And the interesting part is like the expensive part was to train that robot, okay? The expensive part is not to run the thing, because the thing just runs idly. Like basically, it gets a post and says positive, negative. It's very fast. How to train it is doing the whole thing that I just talked about. Basically, you would have to have a bunch of solutions, okay? Like, what's the right solution, okay? What does like a positive post look like, right? That is like a very abstract thing. Like, how can you train a computer to tell if like look at your Instagram or whatever, like any type of post, is this a positive post or a negative post? Like, how can you program that, right? So basically what he did is you need to find like in order for the algorithm to work, right? As I show my thing here, this is important to understand too. In order for the algorithm to work, you need to have a goal metric, okay? My goal metric is easier when I have something more defined, like a route, and I want the route to be efficient, right? So if I want my route to be as efficient as possible, right? So, and it's easy to define that. Shortest route, basically make the route smaller, means more efficiency, right? Less turns, I turn less, equal I lose less speed, more efficient. No overlap, no clean the same place twice. Easy. I have my goal metrics, my good solution, my GigaChat solution, right? How, when you're talking about sentiments, how can you tell what's right or wrong, right? Like, that's a very subjective thing. We could say it's subjective, but like we kind of know. Like, if you look at something, you can kind of tell that something is a positive. I hope I don't get something insane when I click this, but let me see if like if I show you something that these guys post, you can probably tell. Okay, well, look at that. Look at that. Is that positive or negative? Negative, right? Everyone could tell it's negative, right? But how can you program a computer to tell that that's negative, right? Well, okay, so now I'll tell you what that guy did. Basically, he got a bunch of the posters from here that kind of know the lingo of these people, right? And he told them basically rate this post good or bad. If you ever play video games or things like that, you maybe get prodded sometimes that they tell you like, did you have fun this match? That's actually super scary, because what they're doing there is they're actually prodding you to see what type of it's actually crazy when you there's a debate about this, the whole like matchmaking thing. I don't know if anyone play Call of Duty. You heard about the matchmaking thing? Have you heard about it? No.
Buy skins or something. You get
No. It's actually some of the most like it's like an abusive drug dealer. It's actually insane. This is what they do. So like, if you guys play Call of Duty, you guys did you have fun this match, right? Mm-hmm. Okay, let me tell you what they're doing to you. It's actually insane. But it's crazy. So, with the did you have fun this match? They gauge if you had fun or not. Like they ask you if you had fun or not, right? But what does that mean? Usually, what that map onto is that people only have fun when they destroy someone else, right? What does that mean? So they want you to play their game more. So they're gonna optimize for that. So what that algorithm ended up producing, and this is actually how the Call of Duty matchmaking is set now. It actually doesn't match you with people from your same skill level. It 10,000% does not do that. Like you would think that it does that, right? Like you have like some sort of MMR that like it matches you with people that are around your skill level. It doesn't do that. What it does is that it will basically give you one match where you destroy everyone, okay? And then it will make you get destroyed by someone else. And that way it keeps like your dopamine up, down, and makes you keep want to play. It's actually insane. And it's like open source. You can go look it up. But whatever. But basically it does that. Like it will. And how do they determine that? By basically that. They notice that people only have fun when they destroy everyone else in the lobby by asking players basically. And they notice that people don't have fun when they get destroyed, no, they don't. When they get destroyed, it's like whatever, like they don't care. When people don't have fun, when they say like I didn't have fun, is when the match was really close actually, which is actually like that's kind of to me it's like the sad part because I enjoy a good match, but the thing is that for most people that's not fun. Like to go really hard against someone when the scores are very like close together. When you go hard and then you end up losing, it's like it's overwhelmingly bad. It's overwhelmingly good on the other side, but I think, judging by what they did, it looks like the overwhelmingly bad beats out the overwhelmingly good of like winning a close match. And that's done how through everything that I've been describing right now. You need why I'm saying this because for them to actually feed the AI that the AI does the matchmaking, right? The AI basically takes because you have so many variables, right? Like the KD plus like this. You could even like add like the survival rate of the person, like MMR, like a million things that you could add like as variables. And it basically what they optimize the AI for is like how can we get the highest level of enjoyment per match per player, and that's like their metrics. And they can only know if you enjoy the match if you say yes. Like, did you enjoy the match? Yes. And the same goes for this. Okay? Any questions about that? Anything else? Cool. All right. Well, thank you. I'm gonna be. It's cool that this is gonna be the room for like talks now. Let's go to the actual lab now. We can actually do robot stuff now. So yeah. So every Thursday you can catch us here. Cool stuff. So